We are going to work on some equations for this video. Now remember, we are always wanting to solve for the variable. Get the variable by itself. Now in this equation, we have 3x minus 8 equals negative 14. This is saying that both sides are equal. So I can do anything I want to, as long as I can do it to both sides. I could add 100 to this side, as long as I added 100 to the other side. Of course, that's not going to help me very much. I'm trying to get the variable all by itself. So, let's start with this equation. First of all, look for the variable. There it is. You see the x? And I see that I have a 3 multiplied by my x and an 8 subtracted from my x. And this is like I'm undoing. So I'm doing the order of operations backwards in a sense. So I'm going to get rid of the negative 8 first and then the 3. I'm working my way to the variable. And I'm going to work and work and work until I get that variable all by itself. So let's begin. What's the opposite of subtracting 8? Yes, you are right. It is adding 8. But if I add 8 to the left side, I have to add 8 to the right side. Now let's work on the left side. I have 3x and I have a negative 8 and a positive 8. They cancel out. I planned it that way. So that will leave me 3x equals, on the right side, I have a negative 14, a positive 8. Now say that in your head. A negative 14, a positive 8. You will subtract, and I will get 6. And will it be positive or negative? My largest number is negative, so I will have a negative 6. Am I done? Is x by itself? No. It is being multiplied by 3. So what's the opposite of multiply by 3? You are correct. Divide by 3. But if you divide the left side by 3, you have to divide the right side by 3. Well, these 3's will cancel. I will have x equals negative 6 divided by 3. That will be a negative 2. And so my answer is x is equal to negative 2. Now you can always take your answer, plug it into the original equation, and make sure that it does make this equation work. Let's try another one. I have the equation 13 minus 8x equals 5x plus 2. Oh my goodness gracious. Folks, I don't have x just on one side. I have x on both sides. Well, I don't want x on both sides. Well, make sure that each side is as simple as it can get. But I don't want to look at 2 variables. Get rid of one of the variables so I can just concentrate on one variable. Now, it doesn't matter which one you get rid of. My goal is I'm just going to get all the variables on the left and the constants, the plain numbers, on the right. You don't have to do it that way. I could get all my variables on the right. Okay, how do I get rid of this positive 5x so I just don't have to look at it anymore? Well, look in front of it. It's a positive 5x. What's the opposite of adding 5x? Subtracting 5x. But if you subtract 5x from the left side, you have to subtract 5x from the right side. Well, let's see what happens. I will bring down my 13, negative 8x, and a negative 5x. Well, that is a negative 13x. On the right side, would you look at that? The 5x and the negative 5x are gone. Out of there. I planned it that way. I will have 2 left. And now we're down to a regular 2-step equation. I have 13 minus 13x equals 2. So now I only have to look at one variable. I am solving for this x. I'm going to get rid of this 13 first. It's a positive 13. What's the opposite of adding 13? Yes, you will subtract 13. But if you subtract 13 from the left, You have to subtract 13 from the right side. On the left side, I have negative 13x. On the right side, a positive 2 and a negative 13. Opposite signs, you will subtract. I will get 11. Keep the sign of the largest number. Is x by itself yet? No. X is being multiplied by negative 13. What's the opposite of multiply by negative 13? You will divide by negative 13. But if you divide the left side by negative 13, you need to divide the right side by negative 13. Look what happens on the left. Those negative 13s cancel out. I planned it that way. I will have x equals, on the right side, negative 11 divided by negative 13. That will be a positive 11/13. Let's try another one. I have 6 times x plus 3 equals 4 times x minus 1. Whew, okay, this is an equation. I see my equal mark, but I can do some simplifying on each side first. So I'm going to do a little bit of distributive property. Do you see this 6 that is right beside this parentheses? That means 6 times x plus 3. Not just 6 times x. It's 6 times the entire parentheses. Distributive property. So 6 times x will be 6x. 6 times 3 will be 18. On the right side, I have more distributive property. 4 times x minus 1. Don't forget, 4 times the entire parentheses. If there is 100 things in there, I would have to multiply 4 times all of them. Luckily, we only have 2 things, x minus 1. So let's go. 4 times x is 4x. 4 times a negative 1 is a negative 4. Okay, I have simplified each side as much as I can. I can't put anything else together. 6x and 18, those are not like terms. 4x and a negative 4, not like terms. So let's start solving it. Let's start doing things to both sides. My issue here is I don't have one variable to solve for. I have 2. Well, that's easy enough to get rid of. Let's get rid of one of them. Do you want to get rid of the 4x? If you do, subtract 4x from both sides. Do you want to get rid of the 6x? Well, that's fine. Subtract 6x from both sides. But whatever you do, do it to both sides. I am going to try to get my variables on the left, my constants on the right. So I'm going to get rid of the 4x. What's the opposite of adding 4x? I will subtract 4x. But if you subtract 4x from the right side, yes, you're right. You have to subtract 4x from the left. On the left side, I have 6x minus 4x, and that will be 2x. Don't forget to bring down your positive 18 equals. And look what happens. Sure enough, those 4x cancel, leaving me only negative 4. My equation is looking a little bit better. Over here with the variable. Keep your eye on the variable. There's the variable. It's multiplied by 2, added to 18. Remember, I'm working my way backwards, trying to get the variable all by itself. What's the opposite of adding 18? You will subtract 18. But if you subtract 18 from the left, you've got it. You've got to subtract 18 from the right. Sure enough, these 18s will cancel out because that's the way I planned it. On the left side, I will have 2x. On the right side, do not make a careless error here. Negative 4 and a negative 18. If you have negatives and even more negatives, same sign. You will add them and keep their sign. I am not done yet. X is being multiplied by 2. I will divide by 2. But if you divide the left side by 2, you've got it. You have to divide the right side by 2. X will equal negative 11. So my answer, x is equal to negative 11. I could take my answer, plug it into the original equation just to see if it works. Let's do that just for the fun of it on this one. If I had x as negative 11, that would be 6 times negative 11 plus 3 is a negative 8. And 6 times negative 8 is a negative 48. On the right side, I would have 4 times negative 11 minus 1 would give me negative 12. And 4 times negative 12 is negative 48. Yes, that does equal. Aren't you glad you knew a little algebra? Otherwise, you may be sitting here all day long trying to figure out what x could be. And that's not magic, that is mathematics. It's looking a little bit more exciting now, isn't it? Would you look at all those fractions? You know, I don't like fractions either. So let me tell you how to get rid of them. Okay, I have rewritten my equation. And my issue here are that these fractions look a little scary. So let's find a common denominator. 3/4 n, that is over 4. 16, well, that's just over 1. 2 is just over 1. And then we have negative 1/8 n. So I need the least common denominator for 4, 1, 1, and 8. So 4 and 8. What will 4 and 8 both divide into? They'll both divide into 32, so I could use 32. But is that my least common denominator? I could go smaller, and the number would be 8. And remember, I can do anything I want to as long as I do it to both sides. So I'm going to multiply both sides by my least common denominator, 8. So if I multiply the left side by 8, I need to multiply the right side by 8. Now we need to use the distributive property. This 8 needs to be multiplied by each term in this parentheses. This 8 needs to be multiplied by each of these two terms. Sometimes it is easier to take your equation and multiply each term times 8. Remember, whatever you do to one side, you have to do to the other. And when I multiply both sides by 8 and then use distributive property, I will have 8 times 3/4 n. Well, watch this. Remember, you're multiplying fractions. 4, we're going to both of these. 4, we're going to 4 one time. 4, we're going to 8 two times. 2 times 3n is 6n. Would you look at that? No fractions. Now, I didn't have a fraction here. Nothing will cancel. Just 8 times 16, and it is 128. On the right side, 8 times 2 is 16. And look here. 8, we're going to 8 one time. Same up here. I just get negative 1n. No fractions. I planned it that way. So once again, in order to get rid of all those fractions, I multiplied everything by the least common denominator. I multiplied the left side by 8 and the right side by 8. And I actually like doing this step, putting 8 by each term. That way it's easy for me to cancel and keep up with what I have. So let's continue solving this. I have variables not just on one side. I have it on both sides. Well, that's no problem for us. Get rid of one of them. How do you get rid of a negative 1n? I will add 1n. But if we add 1n to the right, I have to add 1n to the left. On the left side, I will have 7n plus 128 equals 16. And now I am down to a basic two-step equation. I have n, it's multiplied by 7, added to 128, which one do I get rid of first? Well, I am working my way to the variable. It's like I'm doing order of operations backwards. To get rid of a positive 128, I will subtract 128 from both sides. On the left side, I have 7n. On the right side, I have a positive 16, a negative 128. I will subtract. I'll get 112, and that will be a negative. I have a positive and a negative, so you subtract and keep the sign of the largest number. Am I done? Is the variable by itself? No. It's being multiplied by 7. So I'm going to divide both sides by 7. N will equal a negative 16. I'm going to do one more equation that has fractions in it, but I'm going to do this two different ways. The first time, I see 3/4 x plus 5 equals negative 10. I do see a fraction, not a lot of fractions, but I see the fraction with 3/4. Now remember, we're trying to solve for the variable. But the only fraction that I have is right here with the variable being multiplied. So I'm going to get rid of this positive 5 first. What's the opposite of adding 5? Subtract 5. But if you subtract 5 from the left side, you have to subtract 5 from the right side. What happens to those 5s? You've got it. They cancel out, just like I planned. I will have 3/4 x on the left. On the right side, do not make a careless error here. Negative 10, negative 5, say it in your head. A negative 10, a negative 5, same sign, add, and keep that sign. Now watch this smooth move right here. You see, x is being multiplied by 3/4. I am supposed to divide by 3/4. Do you remember in elementary school when you had to divide by 3/4 or a fraction? Wasn't that the same thing as multiplying by the reciprocal? Remember that? Instead of dividing by a fraction, you would multiply by the reciprocal. We are going to use that same move right here. I am down to just the variable being multiplied by this fraction. So x is being multiplied by 3/4. I am supposed to divide by 3/4. But I know that is the same thing as multiplying by the reciprocal. But if I multiply the left side by 4/3, I have to multiply the right side by 4/3. On the left side, the 3's will cancel. The 4's will cancel. I will have x equals, on the right side, I'm just multiplying these fractions. You can multiply straight across and then reduce. Or I could say 3, we're going to 3 one time. 3, we're going to 15 5 times. Negative 5 times 4 is a negative 20. Now I have moved our problem over here to the left, and I'm going to write this problem again. 3/4 x plus 5 equals negative 10. Now some of y'all may have thought when you first saw that is, oh, there are the fractions, let's get rid of the fractions. Well, let's do it that way. Let's multiply everything by the least common denominator, which is 4. So I'm going to multiply the left and the right side by 4, which means you're multiplying each term by 4. Don't leave anyone off. You're multiplying each term by 4. You will have 3x. 4 times 5 is 20. 4 times a negative 10 is negative 40. Now look, we don't have any fractions. So let's just continue solving this. I will subtract 20 from both sides. On the left side, I will have 3x equals. On the right side, a negative 40 and a negative 20. I'm going to get lots more negatives. It would be negative 60. I'm not quite done. I will divide both sides by 3. X will equal negative 60 divided by 3 is a negative 20. Would you look at that? The same answer. So the second method, what I did was I wanted to get rid of the fractions immediately, and I multiplied every term by the least common denominator and still got x is equal to negative 20. The first method I used, I realized that the only fraction there was with the variable. So I got rid of the positive 5 first. Then when I got down to one step, the variable being multiplied by a fraction, I chose to multiply by the reciprocal. And we still got the same answer. And that's not magic. That is mathematics.